Welcome everyone to another exercise in the workbook statistics. This time we're going to talk about the topic of probability theory. So let's have a look at the exercise. Here we have in the food court of an outlet center, 3 fast food restaurants exist. The first restaurant is frequented by 21% of all visitors. The second restaurant is frequented by 49% of all customers. The rest of the customers eat at the third restaurant. Then we also know 82% of the customers of the first restaurant are satisfied, 89% of the customers of the second restaurant are satisfied, and for the third restaurant, satisfaction levels are at 61%. That's the information we are given. Then our first task is, what is the probability that a customer of the food court is satisfied with the food? B. What is the probability that a dissatisfied customer has not eaten in one of the first 2 restaurants? And finally, what is the probability that someone eats in the first 2 restaurants, assuming that no customer eats at both restaurants? Well, let's work through these 3 parts step by step. So we start with the first one. Here, what we actually want to know, customer is satisfied, customer is happy. And what we know is, on the one hand, his happiness depending or conditional on the restaurants where he ate. And we also know the share of the restaurants in the total, how many customers frequent them. Well, whenever we have a structure like this, we have these conditional probabilities. And we want to have the unconditional probability, then we can use the theorem for the total probability, because that's more or less what this is about. This is the total probability based on these conditional partial probabilities. Well, how do we go about this? We go about this like calculating a weighted average, with these values being the weights. Since they add up to 100%, that's actually pretty neat. So what we're going to do here in this case, simply multiply the conditional probability, happiness conditioned on restaurant 1, with probability of eating in restaurant 1. Then we're going to do this for the other 2 as well. So in the end, all these different separate parts are more or less the probability of being happy and eating at restaurant 1. That's what we get when we multiply them. So if we do this for all of them, we have for all restaurants the probability that you are happy if you're eating there. And if we add this up, we get the overall share of happy customers. So yeah, we're going to do this. We're multiplying these values, these values, these values, and adding all of this up. So we insert the values and get as a final result 79.13%. That actually also looks like a decent enough result because, as I said, it's more like a weighted average of the conditional probabilities. If this is a weighted average, meaning this value we calculated down here has to be between the largest and the smallest of these values. So it needs to be somewhere between 61 and 89. Well, definitely is. So that's actually a pretty good result in this case. Well, that was already part 1. So let's continue with the second part. In the second part, what we are looking for is the probability that someone ate in restaurant 3 under the condition that he is not happy. That's why we put the complement up here. Well, what do we already know? We already know the probability that someone is not happy by simply taking the result from the previous exercise, from part A, and subtracting this from 100%. Because, that's the share of people who are happy. If I subtract this from 100%, I get the people who are not happy. The 20-point-something%. We know from the exercise that 30% ate in restaurant 3. And, we can calculate this conditional probability as well. Because we know that of those people who ate in restaurant 3, 61% are happy. So we know the conditional probability that someone is happy if he ate at restaurant 3. So if we subtract this from 100%, we get those people who ate at restaurant 3 and are not happy. That's a 39% here. Well, if we have these 3 values, we can actually use the theorem of Bayes to calculate what we are looking for. Why? Because, well, theorem of Bayes is a good application, good tool to use if we have one conditional probability and are looking for a conditional probability where these 2 events are just switched. And that's actually here the case. And we just need the total probabilities for the 2 events, which we also have here, and we can simply use theorem of Bayes. How does this look like? Well, for the theorem of Bayes, we take the, I call this here counter probability, where the 2 things are switched. We multiply this with the probability of the condition occurring, that's this one, and we divide by the probability of the condition we are looking for. That's simply the formula for the theorem of Bayes for 2 possible outcomes. Well, we can insert our values into this formula and we get as an end result 56.06%. So the chance that someone ate in restaurant 3 under the condition that he is not satisfied is roughly 56%. Well, so much for part 2. This leaves us with only one part to go for. That's the third part. And in the third part, we're looking for the probability that someone ate in restaurant 1 or in restaurant 2. That's what we can express with the union here, union of the 2 events. But the union always means ate in 1 or in 2 or in both of them. That's why we have to subtract here the probability of someone eating in both of the restaurants. Because this was explicitly mentioned in the task, not those people, or we can assume that no one eats in both of them. Well, whenever we have something like this, we're going to use the so-called addition theorem. For this, we need the probability of eating in restaurant 1 or in restaurant 2. And we have both of them from the exercise. We subtracted this part. Well, if we actually subtract this from the addition theorem, this leaves us just with those 2 probabilities we have to add up. If we do this, we get as an end result 70%. And that's actually a pretty roundabout way of solving this exercise, because we could, even without reference to the addition theorem, automatically have come up, well, we could just add up these 2 numbers. And that would be our end result. But well, that would be the more or less really correct way by using the correct formulas to getting this result. And that's also why we can simply add them up. Well, that's then everything there is to this exercise. I hope you enjoyed it. I say goodbye and see you next time.